I don't know, some of you may have heard of it. It's called the law of sines. I call it the sine rule, but that's just my name for it. So if you hear me saying the word sine rule or the word sine rule, I mean the law of sines. So let's start with a skill building exercise. We are now going to look at finding missing angles and missing sides for any triangle, but in particular, triangles that are not right angled. So if some of these triangles look right angled, well, you pretend they're not, because they're, you know, that one can be 89 degrees, right? Just any triangle at all. And the first thing that we need to be able to even use the law of cosines, and then after that, the law of cosines and the law of sines, is that we need to know how to name the triangles. When it was SOHCAHTOA, didn't we name them opposite, adjacent, hypotenuse, right? And we had SOHCAHTOA, and that was great. When you've got a triangle and there are no right angles, we name them by the angles are called capital letters. So this is angle B, this is angle A, and this is angle C. So we name angles by capital letters, and we name the sides by little letters. So angle A, the one opposite it, is little a. Angle B, the one that's opposite, is little b. And angle C, the side that's opposite, is little c. Do you see how you name the sides then? The side is opposite the angle. So this side, little c, is opposite angle, big C. Does that make sense? As a kind of consistent way to name sides and angles. And we need to name them this way so that we can, when we use the formula, we know what goes where. Right, here's another one. This one here, the QR side. What name do we give to that side? The one my finger's going up and down. The one Q, yeah, little baby P. And what will we call the one PR? What will its name be?
Q.
Little Q. And obviously, little r. Okay, here's another one. I'll do this one. Right, for this triangle here, angle G is this angle. This side opposite it is little g. This is angle F, the side opposite is little f. This is angle H, the side opposite is little h. Are we comfortable that if I gave you a triangle, you'd know what the little sides are called, right? The three names for the little sides. If I called, you know, the angles, if I told you them. So, can we call that done? Do you need more of these? Or are you comfortable without you name the sides? We're good? Okay. Now we're going to use the law of sines to find missing sides. So I'm just drawing any old random shaped triangle. So nothing's to scale here, right? So don't pay attention to the scale. Let's call this guy A, let's call this one B, and let's call this one C. And this angle in here is going to be 31 degrees. Okay. And this angle here is going to be 75 degrees. That's good. And what shall I tell you? I will tell you that this side up here, let me just check. If you're not careful, you end up putting ones that don't make sense. Okay, this guy here is going to be 15. And you are being asked to find that side there. So when you have a triangle that's not right angled and you're given information, in this case, 2 angles in one side, you should be able to find any given missing side. In this case, oops, can I change that? We'll make it that one. You can find any missing side you like. I'll show you how to get that one there, right? So this is the steps I would use. Step one is name the sides. So in this case, this side is little a, this side is little c, and I know that's got an x on it, but isn't it also little b? Are we comfortable with that? Little c, little b, little a. Step one, name the sides. Step two, write down the sign rule and choose the appropriate pairs of equations. The sine rule looks like this, also called the law of sines. The sine of angle A divided by the side little a is the same number as the sine of angle B divided by the length of side little b, and that's the same number as the sine of angle C divided by the length of little c. And when I write down here, write down the sine rule, that's this, and then choose the appropriate pairs of equations. This is what you do. In this question here, you know angle B, so little check mark. I know angle A, a little check mark. I know little a little check mark. Aren't I trying to find x, a little check mark? Do you see that there are two pairs of equations, those two, where they've all got check marks? Either because I know the thing or I'm wanting to find the thing. That's what I mean by choose the appropriate pair. Can you imagine in a different story, it might be A's and C's that we use, right? And maybe in another story, it's the B's and the C's, right? Depends on what angles they tell you and what sides they tell you, which is the appropriate pairs, right? So you've got that. Are you comfortable about that choice? Right, now step 3. Put in the values that you know. And then find the missing value. So I have right now got this version of the sine rule. I'm going to use this pair. And you only use 2 out of the 3 at any given question. So it's going to be sine A over little a is sine B for little b. I know A is 75 degrees, and I go the sine A 75 degrees over 15 is equal to the sine of 31 degrees over, instead of writing little b, I'll now write x. Are you comfortable about that substitution and where I got the numbers that I got? Are we good? Right, now, you are going to have to solve an equation, and they always, because of the structure of this, can you see it's going to be a cross multiply thing, right? You're going to always end up cross multiplying. So if you cross multiply this way, you have x times the sine of 75 degrees equals 15 times the sine of 31 degrees. So far, so good? Okay, what do I do to both sides to find x?
Divide by the sine of 75.
Right, and I normally wait until this stage to go near my calculator. Now, could I find all these guys to decimal places? But wouldn't that be really wasteful of time and really ugly as well? So I'm not going to. I'm going to do it now. And little mistake, which I caught myself this morning when I was doing a practice one on these. Make sure that you're in degrees. Because if you're in radians, I mean, you'll type in numbers and the answer will be wrong and you'll think, no, I don't know how to do this. It's such an easy mistake. Make sure you're in degrees. So 15 times the sine of 31 divided by the sine of 75. And oh, that was sheer luck. Would you agree the answer is 8 to 2 decimal places? 8.00. That's a really nice answer. You know, normally you're going to get 1.23456 and you round it off to whatever accuracy they ask you for. And that's it. That is how you find a missing side from any triangle if you want to use the sine rule. Are we good on that? Any questions? Okay, that looked like it went fine. I'm just going to pick another one and see how it works out. Oh, why don't I pick something like question 1 straight out the homework? It looks something like this. This is x. This is 98.4 degrees. This is 24.6 degrees. And we're being asked, and this number up here is 334, and we're being asked to find x. So far, so good? Right, now this one's got a little bit extra to do, but we'll wait for a minute and see what happens. The 334 is little a. This side over here is little b. And this side here is little c. Are you happy about the naming of the little sides? Now, I'm going to show you something that's going to look wrong, and then I'm going to show you how to fix it. What we would do now is we'd write down the rule of sines. And we should be checking off everything that we know or want to know. Well, I know angle B, and I know angle A, and I know little a, and I'm trying to find little c. Do you see that doesn't work? Because don't we need to have 2 pairs where we know everything, or at least are trying to find everything? Now, when I look at this, since I want to find this guy, what's the problem? The problem is I don't know angle C. But pause for a minute. Can I find angle C?
All angles in a triangle add up to 180.
So if I want to, couldn't I find C by taking 180 and taking away the 2 that we know? So do you see in this case, angle C was hidden from us? They never told us it, but they did tell us enough to find it. So be on the lookout for that, because they do it quite a few times. Take away 98.4, add 24.6, close it, and I'm looking at, would you believe it? It's a nice number. It's actually 57. Wow, okay. So check. That means I can now pick A and C. Would you agree? I know everything, or at least I'm trying to find it. All checks. So sine of A over little a, sine of C over little c. So it's going to be the sine of 98.4 degrees over 334. And that's going to equal sine of C, which is 57 degrees, divided by x. Do a little cross multiply. X times this ugly sine is 334 times this guy. And to find x, won't we divide both sides by the sine of 98.4? And I put the wrong place, sorry. There, got it in the right place now. And clear. 334 times the sine of 57 divided by the sine of 98.4 and to what accuracy? To 2 decimal places. So 283.15. We are done. That's about all they can do really to a basic triangle question to make it a little bit harder for you. Are we still good? Right. Any questions? Let's see. Okay, this is a version of question 5. In question 5, they do things a little bit differently. You have a triangle. You're told angle A is 20 degrees and the angle A is here. You're told angle C is 100, so I'll put it here. And that's angle B. And you're told little b is 4, so that's 4. And you're told to find all the other missing sides and angles. Right, so that's all we know right now. So I guess I should put the names in, shouldn't I? That's little b, this is little a, and this is little c. So we have to find every angle and every side that's missing. What do you think I should find first? A missing angle or one of the missing sides?
To find B, the angle B.
Okay, now if you want to find angle B, don't we use the 180 take away the other two? Which is 120, 60 degrees. Really nice number, right? And might as well put it in there. And now I'm going to write down the sine rule. And if you check what we know, well, we know all 3 angles. And we also know little b. Now, since we are being asked to find all the missing sides and all the missing angles, well, now it's just missing sides. We have a little choice here. It doesn't really matter what you pick first, but don't we have to pick one? So what do you want to pick? Find A first and then get C, find C first and then get A. You know, it doesn't matter, right? So which one do you want me to go for?
A.
Okay, let's do A, which means sine A over little a, sine B over little b. It's going to be the sine of 20 degrees over A is going to be the sine of 60 degrees over 4. A times the sine of 60 is 4 times the sine of 20. Divide both sides by the sine of 60. And we're done. So 4 times sine of 20 divided by sine of 60. And they want 2 decimal places again. So that rounds up to 1.58. Great. Right, last guy to find. So I guess I should write down everybody we found. We've now found that this side is 1.58. Okay, so there's only one guy to find C, right? This one here. Could I use B and C to find little c? Could I use those two? Yeah. Could I have used A and C? Yeah. Do you think it matters? So we have to use this one, right? Because we're trying to find C. Which one do you want me to use? The A or the B one?
Well, B is cleaner, so
Okay, B is cleaner. I like your thought process. So sine of B over B, sinus angle C over little c. It's going to be sinus 60 degrees over 4 is the sine of 100 degrees over c. Cross multiply. Isn't it becoming quite mechanical now? Aren't I kind of doing the same thing over and over again, just with different numbers? A lot of people like that because if it's a process that is kind of the same each time, once they figured out what the process is, they very rarely get the thing wrong, apart from, you know, the usual mistakes, not being in degrees or forgetting to hit the right button. And I'm looking at, to 2 decimal places, 4.59. And we are finished. We now know everything. Good. I'm going to give you one to try. I feel much more comfortable if we do one. I'll just make up some numbers and we'll see how it goes, right? Hopefully it'll go well. Here we go. Call this A, call this B, call this C. We are told that this is 40 degrees. This is 75 degrees. And this guy down here is 210. Okay. I'm giving you very little time, so try and get all 3 parts. Find the missing angle and the length of the other 2 sides. So, and 2, 3, go. You got it. 3 minutes from now. Okay, let's get this show on the road. I would hope that you all found angle C first, right? You know that that's kind of what you need to do in this case. How much is angle C? Someone just call it out.
115.
65.
65. So this adds up to 115 and that leaves 65. So you were both answering what you thought I asked. So that's fine. Right. Now, if I check off everybody that we know, which are now all three angles, and this is called little c, right? This will be called little b and this will be called little a. I know little c. So if I want to find a missing side, won't I use, if I wanted little b, wouldn't it be these two, the b and c I would use? If I decide to find little a, will it be the a and the c that we use? You know, it doesn't matter, right? We're going to get the right answer. Anybody want to volunteer what they went for first? A or C? Would you go for A or B, I should say? Would you go for first?
A and C.
Okay, so we'll take that one. So you would be doing sine A over little a and sine C over little c. And that would turn into the sine of 40 degrees over unknown A and the sine of 65 degrees over 210. So A times the sine is 65 degrees will be 210 times the sine of 40 degrees. And you take this guy, and you divide both sides by the sine of 65. And I didn't tell you, so well, let's just assume that I did tell you 2 decimal places. So 210 times the sine of 40 degrees, and then divide everything by the sine of 65 degrees. And the answer I get is 148.94 to 2 decimal places. Does that look good? Does that look good? Thumbs up, great. Now, if you wanted to do B first, I'm not going to do this all the way to the end. Wouldn't you be using sine B over little b? And I'd probably go back to sine C over little c again. And eventually you'd get B. Has anybody got a number for B? Did you actually get the whole thing done, in other words?
Should be 223.81.
How does that look, guys? Now, you might get some different rounding off because, you know, if you did B and then used it to get A, or if you got A to using it to get to B, you might find that's 83 or 79, and that's okay. That's just rounding off issues. You can't, you know, that just happens. So if I give you a triangle and I give you 2 angles on a side, are you good for finding any angle or side that's left, right? So now we're going to look at how to find missing angles. We haven't done that yet. Well, I guess we have, but not the type that we're going to do now. How to find missing angles. Now, before we get into the details of it, which is very similar to this, let me tell you what can happen. When you get these questions, right, the one we've just did, there was only one missing angle for A, and it is what it was, right? And when you found the little a and the little b, there was only one answer, and that's what it was. In other words, everything was unique, right? That was the only answer for A and so on. This is not true when you do missing angles. Three things can happen. One, you get a single value, right? Only one angle for the angle. Let's call the angle theta. Second possibility, no angle is possible. And that will happen. You're going to be given questions which are essentially impossible to do. And when that's the case, I think you're meant to write down something like not possible, right? And then there's a third possibility. Any ideas what the third thing that could happen in this kind of triangle story?
Multiple values?
Yeah, it is sometimes, not a lot of the time, but sometimes you can get two possible, both correct, values for the angle theta. And I'll go and find a question from the homework. We'll show you how that works. But essentially, can you imagine that you might get the acute angle that works, but there might be an obtuse angle that works, right? The same information, right? These two are still the same size, right? But the angle in the middle might end up being a little guy or maybe a big guy. So let me talk about this possibility first, just to get out of the way. If you find an angle theta of any size, let's say it's 32 degrees, the other possible angle, because sometimes there's two, the other possible angle will be 100, call it theta, 148 degrees. Where the heck is that one coming from?
180 minus 32.
Yeah, you could get 32, but isn't it possible that you might be getting the other guy, the 148, because that's what you get when you take 32. You remember those things where we looked at, there are two answers for, you know, the sine, two answers for the cosine, all that carry on. That's basically coming here. Now, so when you want to see the second answer, just take 180 and subtract the one that you got. This one you'll get from your calculator, right? Right, the calculator always gives you the acute angle. And you might say, well, that means that there's always going to be two answers. Well, let me kind of show you why it might not always be the case. Can you imagine that you've got a triangle where you already know that this angle here is 100 degrees, and you're trying to find this guy? Right, there's always going to be room for 32. Is there room in this triangle to get another 148? Well, if this is 100, can that be 148? Think about it. No, because wouldn't that be too big, right? Now, if you get a triangle where this is 10 degrees, right, that's already known, and you're trying to get theta here, isn't it possible, 32 is always possible, but isn't it also 148 could happen? Do you see that there's enough room for it? So when you're doing these questions and you're looking for a missing angle, if the one, because you're going to know one of the angles, if the one that you know is so big that it makes that impossible, then you know there's only one answer, 32. If the one that they give you is small enough to make this possible, then you're going to get two distinct answers. So that's how you can tell. Now you might say, well, how do you get no angles possible? When you do the calculation, you're going to end up with something like the sine of theta is 3.2. And you know you can't get sines bigger than 1. And when you try and do inverse sine, the calculator's going to keel over and die and say error. So whenever the calculator says error, you know that no angle is possible. So that's the three possible things that could happen. So I'm going to randomly make a triangle, making no attempt to be accurate, to be scale. I'm going to call it ABC because I like those. Somebody give me an angle for A, and I want you to make this angle less than 90. So just give me any angle you like, less than 90.
73.
73 degrees, right? We've got 73 degrees. Now, I need to know this side up here called little a. Give me any number you like.
17.
Okay. And now I'm going to pick little b, and I'm going to tell you that one. So pick a length for little b. Give me a number for that one. Any number you like. How
27.
big do you want? 27, right. So would you agree this is a pretty random triangle, right? So the chances are, I don't know which yet, one of these three things is going to happen. Now, you need to find a missing angle, right? And in this story, which missing angle you can find is actually part of the process. So I'm going to go through a very similar process that we did before. I'm going to name all the sides. So there's A, B, and C. I'm going to write down sine of A over little a, sine of B over little b, and sine of C over little c. And I know angle A, so I'm checking that. We want to find angle B, right? Because I'm telling you that in the question. So check that off. Would you agree that we know little a and we know little b? Is it kind of clear now which pair of equations we're going to be using? Now, if they told me little c, wouldn't I just ignore it because it's not health? Now, since I'm going to use these two, I'll write them down again. Wouldn't the next step to put the numbers in? So let's do that. It's going to be the sine is 73 degrees over 17. I'm calling that theta, so it's going to be the sine of theta over 27. And just like before, isn't it going to be a cross multiply thing? So it's going to be 17 times sine of theta is 27 times the sine is 73 degrees. And then the sine of theta then is what you get when you divide both sides by 17. Now, if I go, 27 times the sine of 73 degrees divided by 17, I get the answer 1.518. Now, to find the missing angle, shouldn't we find the inverse sine of whatever this number is? And I'm doing this deliberately just to show you what the calculator does. If you take the inverse sine of 1.518, watch what the calculator does. Keels over and dies, doesn't it? Is it possible to get any angle whose sine is as big as 1.5? Don't the sines only go from 1 to -1? That's the biggest you get is 1 and the smallest you get is -1, right? There are no other answers. So we have just found theta is impossible. So that triangle can't exist in real life. Right? You could try and draw a triangle where this is 27 units long, right? And that's 73, and this is 17. And you might think, well, it looks like it should work. So let me try and pretend I'm drawing it. Can you imagine for a minute that that's 27 units long, right? And here I draw another line, goes like that. Don't know how far it needs to be, but I make this 73 degrees. And on this side, I draw a line that's 17 units long. Now, can you see that the 17 unit long, no matter what I do, it's not long enough to reach here? Do you see how the triangle's impossible? So if you're wondering how does an impossible triangle happen, there's an example of it happening, right? Convinced? Can happen? Right. Now, let's do one that has one angle that exists, and then we'll do one that has two angles, right? And that way we've covered every permutation. So that one, I don't know what we're going to get, but that is a not possible, right? Which happens. You just seen it happen. So this one is going to be what? This is triangle that looks something like this. This is a version of question 3. This angle is 120 degrees. It's going to be called A. This is 45. This is the angle that they want us to get. And this guy here is 30, right? So there we go. So little a is 45, little c is 30, and little b is there. I'll set up the sine rule. And I know angle A, check. I want to find C, check. I know little c, check. I know little a. Do you see it's A and C this time? Right, there's no confusion here. It has to be A and C. So sine of A over little a is sine of C over little c. The sine of 120 degrees divided by 45 is the same number as the sine of theta divided by 30. A little cross multiplication again. 45 times the sine of theta is 30 times sine of 120 degrees. And that makes the sine of theta then, this guy times this guy divided by that guy. So far, so good. Now, there are two ways to approach this final thing. I want to show you both. The first way is going to be that theta is the inverse sine of this entire calculation. Now, that might be too much for some of you, right? Just too many buttons to press. But isn't that essentially what you would do? Now, the advantage of doing this is don't you not need to bother about having a horrible decimal that you then find inverse sine of? Can't you just let the calculator do it all in one big go? So if you want to do it that way, you can. So it's inverse sine of 30 times the sine of 120 divided by 45. And the answer you get is, well, they want it to the nearest whole number. So the answer you get is 35 degrees. Or you could have found out what that is as a decimal first. So you'd go 30 times the sine of 120 and then divide it by 45. And that gives you 0.577. And then the missing angle is the inverse sine of that decimal. And the inverse sine of 0.577 is 35 degrees as well. Do you have a preference? Do you prefer just not to bother doing anything and just writing it down as a calculator? Or do you feel a little bit more comfortable getting a decimal and turning it out? I have no problems with you doing whichever one you are comfortable with. So that's what you should do. Are we good on that? Now, I said that there's only one angle. But let's prove to you why there is one. If there was going to be another angle, wouldn't it have to be 180 take away 35, right? We've already talked about that. Well, that would have to be 145 degrees. If you look at this triangle, is there enough room for another angle to be 145 degrees? Can you see there's just not enough room? Good. Now, if that was 10 degrees, wouldn't there be enough room for 145? And that would be my second answer. So whenever you get a missing angle, the one that you'll get from the calculator, always have a look at the other possibility to see whether it fits, because that could be that there's two correct answers. Are we good with that?
I'm a little
Yes.
confused.
Okay, go for it. What?
If the answer you get for the other angle, if you
Uh-huh.
subtract 180 from it
Mm-hmm.
and it's greater than the angles you already have?
Not so much greater than the angles you have. When I say, is there enough room for it? I'm kind of doing two things at once. Don't all triangles add up to 180?
Yes.
And if I know that one of them is 120 and I can't do anything about that, right? That's fixed.
Mm-hmm.
When I say, is there enough room for the other angle? Can you see there's not enough room for this 145?
Yes, that does make sense.
That's what I'm saying when I say there's not enough room for it. So I don't care that that's 120. I just care that it's so big there's not enough room for that. To give an example, couldn't that answer there just be 40 degrees and there's still not enough room for it?
Mm-hmm.
Right, 40 and 145 is too much, right? You can only have enough space in your three triangles to add up to 180 degrees, right?
Yes.
If the second angle added to the one you know is more than 180, then you can't use it. Maybe that's a good way of phrasing it, right? If the second angle, this one here, if you add it to the one that you already know about, is more than 180, then you cannot use this second answer. And that means there's only one, right? And that's this guy.
Okay, I guess what would make sense to me, and maybe this is
Right.
where I'm confused, is that if A is 120 degrees
Right.
and the one we found was 35,
That one works.
so then can we find the other angle of the triangle?
There is two, it sounds like you're asking me two things. If
I'm
I say,
sorry.
if you, right, no, it's just me. You're telling me that's 35 and I'm saying that's okay. And it
Mhm.
sounds like, can I find this one? Yes, I can. Don't I add these up and see what's left?
Yeah.
So
Mhm.
yeah, you can do that. But what
Okay.
I'm saying is you cannot use 145 degrees as your theta because that's just not got enough space, right? There's not enough room.
Oh.
So
Oh.
that's what I'm getting. Yeah, this one will work. And when this one works, won't there be enough room for the third one?
Mm-hmm.
And so you can get all three angles. That's going to happen. But
Okay.
you can't have 145 here because 145 and a 120 are more than a triangle can handle.
Yeah.
And that's why this one, in this case, got kicked out.
Okay. Thank you. Sorry about that.
No, it's a good question. And I bet you're not the only one that was thinking about that. Are we good on one angle and no angles? So I guess we need to find a two angle one, don't we? One where there's two possible answers. So let me go hunting for one in this list.
So when there's the possibility of two angles, right? Doesn't that mean the other angle has a possible of two angles?
Yes.
Okay.
By that, do you mean C? Right. Let's
Yeah,
pretend. Yeah. Let me pretend I got a situation that works. Right. Totally different question. But can you imagine this is 50 degrees, and we found out that this guy could be 70 degrees. Right. That was one of the answers. Was 70 degrees, and we know that's going to work. So we can get this guy. We can get this guy, and won't this guy be what's left? So that's 60 degrees, right? But there is another choice. Couldn't it be 110? That one is fixed, right? This could be 110, right? That's the other possibility. And in this case, that and that leaves 10 degrees. Do you see you get two quite different looking triangles in that situation?
Yeah.
So, right. So yeah, that can happen.
And would that one be 20 degrees, not 10?
Yes.
Okay.
Be good. Grace, I think I instead of helping you, I've now puzzled you.
I am very confused. I don't really know what's happening, but
Okay. Let's pretend we started from the scratch. We'll try and take you through. We have a question. I'm not putting any numbers in. Different question, and we have a triangle called A. We've got one called B, and we've got one called C. And in the question, they told me that this angle up here was 100 degrees. So we got that angle and some other stuff that we don't need to write. We went through the math and we came up with angle theta was 50 degrees. Right, we solved it and we found angle theta. Right, in that world then, won't we go up here and we'll say, I'll use green, that this angle is A. A is there, right? It's 50 degrees. Now, in this triangle, what is the size of the third missing angle going to be?
it's 30 degrees, right?
Right, 30 degrees. And that would be a solution. Now, in this world, let's start with the same picture as I had before. What is the other angle that the math tells us you could get instead of 50 degrees? What would the other one as a possible candidate be? How do you find it?
You subtract or 180, right?
So that ends up being 130 degrees. Now I look at my picture here and I say to myself, is that physically possible? Can that really happen? That this angle is 130 degrees. Would you agree that this is a no-brainer? It ain't going to happen.
Yeah.
So that would be a situation where there's only one answer, and that answer is this triangle. We're good with that situation, right?
Yeah.
So let's look at a different situation where there might be two answers that are possible, right? I'll draw another triangle, different question. So different numbers came out. In this question, this guy up here happens to be 35 degrees. And we find A, and we find out A happens to be the missing theta. But this time, it's still 50 degrees, right? Can happen. And we go up here and we say, okay, 50 degrees. That's cool. Yeah, that one's always going to work, right? Now, if this is 50 and that's 35, won't we be able to get the third answer again?
Yeah.
I believe it's 95 degrees, and that is a correct answer, right? That exists. And then we say, well, let's just check out the other possibility. So we put in, back to where we start, the same information, which is that. Now we know there's another possibility here. Isn't the other possibility 180 take away 50? So the missing angle might have been 130 degrees. Now, if you put 130 degrees into this picture, can that exist? Is that triangle possible?
Yeah.
Right. And for this triangle, what's left for the third angle, the angle B then? I believe it's 15 degrees.
Yeah.
Do you see in this story then, there are two correct answers because of the way the numbers happened?
Yeah,
Right.
okay. I don't
And
know, maybe I was thinking about it differently. That makes sense.
Okay, so when you're looking at this question, you sometimes get no answer. That's an easy one. Doesn't the calculator just keel over and die because the numbers don't make sense? A lot of the time, you're just going to get one answer, right? Only one of them work. If you try the other one, it doesn't work, right?
Yeah.
That would be the situation. And then sometimes, less common, you get two distinct answers. And when you get two distinct answers, do you notice that the triangles are quite different? The only thing they share is the 35. These two end up being different numbers. Okay. So let's see if we can find one in that storyline. You know, it's hard to find one when you're looking for one. When I'm looking for one, I bet you'll see hundreds. Come on. Okay, we got one. Here we go. And this one is question 10, or at least version of question 10. And they do the question, and I'll show you what the question looks like so that you can create your triangle. That's all they tell you. So just draw any generic triangle you like. It doesn't matter what it looks like. Just draw that. And then you can call this little a, this little c, and this little b. And since you're told little a is 37, you can put a 37 there now. And little c is 40, you can put a 40 there. Right? And angle A is 31 degrees, you can put 31. So do you see how this information does become a triangle? Right? So you can be given it like this, but this is what you always begin with, right? You need this triangle, and just to suck out the numbers that you need. Now, with a bit of luck, this is going to be a situation where there are two correct answers, two different triangles that both work. So, sine A over little a, sine angle B over little b, and sine angle C over little c. Let's go head count. I know angle A. Oh, and let's find this guy, all right? So I know angle A. I want to find C. I know little c, and I know little a. Would you agree it's an AC split? Good. So the sine of A over little a is the sine of angle C over little c. The sine of 31 degrees divided by 37 is going to be the sine of theta divided by 40. So far, so good. Okay. Next line. 37 times sine of theta equals 40 times sine of 31 degrees. And that makes sine of theta, when you divide both sides by 37, it makes the sine of theta equal to that guy. Can I just do an inverse sine round that rather than doing the decimal, right? So if you want to find the angle theta, right, this angle up here, you will just go the inverse sine of all of that. And this better have two answers because it's meant to. So inverse sine of 40 times the sine of 31, all divided by 37. And great, we get an answer. What do they want it to be? To one decimal place. So how about 33.8? Now, would you agree 33.8 always works, right? The one you get from the calculator is a guarantee to work. What I'm going to do is I'm going to put it into my triangle. So this guy here is 33.8 degrees. So me and my scanning. Start again. This guy is 31 degrees. This angle up here that we called theta is 33.8 degrees. And then to find this angle, don't we just add these up and take them away from 180? So angle B is 180, take away these two guys. So that's going to be 180, take away 64.8. So that makes this 115.2 degrees, I believe. And we have just solved find the missing angles, right? Now let's return back to that question. Remember we had the 33.8 degrees. Who is the other possible answer that you might get? What do you do to find the next possible answer? It's the same thing every time.
You subtract.
Right. Now, if you take 180 and you subtract 33.8 degrees, you get 142.2 degrees. if I put in 142.2 degrees here, do you notice that there's enough room for it to fit? Not a lot, but there is enough. So that means that this answer is also possible. And the third missing angle B is going to be 180. Take away those two guys. So it's going to be 180. Take away 173.2. And that ends up.
How did you?
Yeah.
How did you get 142.2?
I took this away from 180.
Yeah, I got 146.2.
I can't count. Thank you. So that's 177.2. That still works, but it's very tiny. That leaves 2.8 degrees. So you see there's two different solutions to that problem. Is it a little bit clearer?
Yeah, thank you.
Right. Not just you. I'm sure it's the same problem for a lot of people. Are we feeling a bit better? Right. Now, unfortunately, or I guess that's luckily, that was a good finishing point. Because don't we now know how to find missing sides and missing angles in any triangle using the sine rule? So put your last name down for attendance and bye-bye for the time being. I'll hang about if there's any questions. Otherwise, I'll see you tomorrow. It's going to be a short week. We only have Wednesday, Thursday this week.
Thank you.
You're welcome.
Thank you.
I had a question on the homework.
Sure, what you got?
So for section 6.4, on question 15 through 17, it says that you have to find the angles of theta between 0 and 180 degrees. And how do you do that?
Okay, let me have a look. 15, 17, right? So you said find all the angles between 180 and 180. Okay, so we're really just going to be doing it through a calculator. But let me show you how it works, right? If I tell you that the sine of theta is 7/9, then to get one of the two answers, don't you have to find that guy? So the inverse sine of 7/9 is roughly, what do they want? Round your answers to one decimal place. So to one decimal place, this is 51.1 degree. And we've done this today. Where's the other place where the sine function is a positive number like 7/9? Well, isn't it in the second quadrant? There's your second answer. Now I can check that. If I do the sine of 138.9, shouldn't it be very close to being 7/9? And I didn't hit that right. So let me check my subtraction. 180 take away 51.1 is 128.9 there. That proves it. Now I'll do it again. Sine of 128.9 is that guy. And 7/9, you get it's the same number rounded off to two decimal places. Right. Now, suppose I gave you a cosine and it was 7/9. Now we're going to get one answer right out the calculator. So let's get that one out of me. The cosine, or the inverse cosine, I should say. The inverse cosine of 7/9 ends up being 38.9 degrees. And if I do a little picture, 38.9 degrees is that angle there, right? Where else, which quadrant is the cosine positive? Because 7/9 is positive. Where else is the cosine positive? What quadrant? Do you remember, Jason? Which one?
Is it quadrant 4?
Yes. And so if you imagine another angle where that guy is also 38.9, for a cosine, if you want to get the second answer, it's 360. Take away that number, so it's a lot different. It's 321.1 degrees. And I should be able to check that. The cosine of 321.1 is that guy, and 7/9 is that guy, right? So it did work.
Mhm.
Now, if the answer is negative, similar thing works, but you have to do a fair amount more work. So let me show you what that would look like. If I told you that the cosine of theta was -4/5, then theta is the inverse cosine of -4/5. And so the first answer we'll get from the calculator. So let's see what that looks like. The inverse cosine of -4/5. And we get 143.1 degrees. So that is in the second quadrant because it's 140, so it's over here. And that angle is 143.1 degree. And that angle is in the second quadrant. Not a surprise because the cosine is negative in the second quadrant. Where else is the cosine also negative? Which quadrant?
The third quadrant?
Right. Now, what we know is that this angle here is the same as this angle here. That's one of the symmetry things. So we are trying to find that angle, right? The second one. You can do it a couple of ways. Couldn't I just take 360 and subtract that number and get to it that way?
Yeah.
Right, so if I did it that way, the second answer is 360, take away 143.1, which I prefer doing that way. And so that's going to be 216.9 degrees. Or couldn't I just figure out how much that little piece is and then add that little piece to 180 to get the whole angle? And if I did that, you would also get 216.9 degrees because that little piece there is 36. Trying to get my head here. How much is that? Did I subtract that right? Let me check that I did that answer there correct. 360. Take away 143.1. I'm not trusting my brains. Oh, I got it right. Okay. So if you went the other way, you would go 180, take away 143.1, and that would tell me that this piece here is 36.9. And then if you did 180, add 36.9, oh, 216.9 again. So you could get that two different ways. So there's a property that says that if you take any angle, like this angle here, and you have another guy in another quadrant, this angle here is going to be the same size.
Mm-hmm.
That's kind of the rule I'm using there. And it works no matter what you're. So for instance, see if one of my sines is here, that angle in there is going to be the same size. And so all you need to know is what angle it makes with the x-axis. And you should be able to figure out what the other angle is. If it's in the second quadrant or the third or the fourth, you can figure out how much to add or subtract to figure out the second missing answer.
Okay.
Are we good?
Yeah. Thank you.
You are welcome. Do you mind if I keep this on the video so that people who watch it can see it?
No, not at all.
Okay,
Then
thank you.
If I forget it, I can just look at the video again.
Yeah, it helps you as well then. Okay, see you tomorrow.
All right, thank you. Bye.
Bye-bye.